Duran Consulting Engineers is pleased to present this program for calculation and design of residential structures for non-seismic zones. This program comprises many calculation modules, each on different sheet tabs or worksheets, as required for typical calculations of residential structures, which usually present a variety of structural components, each requiring separate calculation or design methods. The link capacity of Microsoft Excel allows for the interaction of data and results, thus saving substantial time and effort. Though some modules can be purchased separately, this program offers the option to work them together in a linkable way. 4 different packages of this program are offered, each with about 5 or 6 modules more than next smaller package. The basic package, Pack 1, would be sufficient for common residential structures, while the full package, Pack 4, would cover sophisticated residential structures, including areas and buildings not usually encountered in large commercial software. The following pages are the different worksheet modules for a variety of structures and components of residential structures. Some of these modules are offered for separate purchase, but some included in the package. It allows the user to apply the Microsoft Excel linking capacity to this module from others in the workbook. Trying to incorporate any of these separate modules into the program independently would cause mismatch information and formulae, and hence results would be incorrect or unreliable. Worksheets and design modules on this program. This program is offered in 4 packages of different size, depending on the selected package for purchase. The following are modules that make part of Pack 4 full, each under the following sheet tabs. Presentation and instructions. DCE, owner and producer of the program, contact information and list of programs for sale. This first sheet is to provide you with our contact information and the initial list of programs that we offer for sale, beside others that are given for free separately in the same website. The list presented on this page, worksheet, is the latest up to the time you purchased and received this program. For newer updates, please refer to the website shown on this page. Gen Instru, General Instructions for DCE software. On this second page, we provide you with general instructions containing operating procedures common to all of our programs, which the user must become very familiar with. Since our programs consist of open, explicit spreadsheets, every worksheet operates in a similar way. This worksheet includes common instructions on all of the spreadsheets programs produced by DCE. Spec Instruct, specific instructions for residential structural design program. This third page instead contains specific instructions for this particular program only. In this case, for residential structures only. DCE does not apply macros or Visual Basic programming embedded in our spreadsheets. Therefore, the user can openly note and observe the different aspects of each program that we offer, with the help of these specific instructions, which are valid for this program only and for the specific purchased version. Tables. ASE 7-10 Wind Pressure Coefficients. Tables on this page are common to most of the DCE programs where wind load pressures are required, with proper instructions for its use. They are formatted specifically for this program as offered and purchased, and it would be not of any help to the client to be instructed of its content and uses or links on the design modules. SSMA, Light Gauge Metal Section Properties by the SSMA and Fastener Tables. The set of tables on this page are also offered for free separately, such that the client can make use of it at his or her discretion. They are formatted here on this worksheet specifically for this program is offered and purchased. However, the user is given the option to enter combined shapes at the very bottom of the main stud and track table. AISC, Structural Steel Shape Section Properties and Other Standard Sections. The set of tables on this page are also offered for free separately, such that the client can make use of it at his or her discretion. They are formatted here on this worksheet specifically for this program as offered and purchased, but the user has the ability to enter data for special sections as he may deem necessary. Lumber, Wood Design Adjustment Factors by the NDS. Tables on this page are only formatted specifically for this program as offered and purchased. It contains many tables that are part of program's use and links on this design modules. Combos, Load Combination Factors per ASCE 7-10. Variables, text, and values on these tables are extracted from the latest ASCE 7-10 code for load combinations. They are tabulated in a way that can be linked to the design modules of this program as needed for programming only. Cover page and table of contents. CVR, automated cover page. This page represents one printable area, main presentation titles and dates, and a non-printable area for the user's entry at the right side. This latter is for creating a small client base and for control of the latest revision of the calculations. Index, table of content. The information on this worksheet is manually controlled by the user. Since the design modules used for the project may include one or more modules, and each module may be repeated as many times as needed, it is up to the user to enter the subtitles and page numbers pertaining to each section as needed. Main input worksheets. INP, Win Condition Parameters. On this page, general input data such as project and task names, as well as date and project number, are the basic header information to be repeated as headers on most of the worksheets in this program. But it also provides with the most important code required win data used throughout the program. Load, gravity load data, and summary of applicable wind pressures. Input data on this worksheet is for general control of gravity loads, linked to several design modules as applicable. It is intended to be used for any material to be designed, but it also provides strength design factors for concrete design in accordance with the ACI 31810 code. Design modules. Clad low, low-rise building wind load pressure calculations for components and claddings. Calculation of C&C is an integral part of any residential calculation. For low-rise buildings in the ASCE 7-10 code, wind pressure is uniform on the walls at a particular zone 4 or 5. Wind pressure depends only on the size of the cladding and the zone at which it is located. Understanding the concept of effective area is of great importance when entering the cladding size. Therefore, limiting the size is necessary by entering the value of maximum effective cladding area. Clad high, high-rise building wind load pressure calculations for components and claddings. This module is not necessarily an integral part of a regular residential design, but many apartment owners require an engineer to calculate exterior window or door wind pressures for repair or replacement, sometimes for special antennas, cabanas, or other claddings. MWFRS, wind load pressure calculations for main wind force resisting system. Wind pressure coefficients and pressures in service condition, ASD, are calculated here directly with data entered on sheet INP. Other wind load pressure calculations for other structures. On the ASCE 7-10, other structures are classified under different types. The time and effort savings obtained with the use of this module are outstanding. CLG 1, Light Gauge Metal Ceiling Frame. This module applies only to standard metal ceiling frames, mostly required for residential building exterior ceilings. This program requires users' intervention for entering data, selecting shapes, and selecting the portions of calculations applicable to his project. JST React, Roof Truss or Joist Reactions. This design module greatly simplifies the painful process of calculating reactions and uplift forces from simply supported trusses when applying the ASCE 7 wind code. Then, they can be easily applied to the main support structure. This program presents most cases of truss types resulting from a standard truss layout, namely trusses, or roof joists, or roof truss joists, jack trusses, hip trusses, and girders. Poly G TRSS, Polygonal Roof Truss Reactions. Architectural design of many houses, especially large residences, require truss layout on a polygonal plan shape, mostly of 6 or 8 sides. This module provides reaction calculations for the two typical trusses that result from most common truss layouts, the hip trusses and main girder. Collar TRSS, Collar Truss Forces and Reactions. Two types of trusses from old practice that have proved resilient to be abandoned are collar trusses and collar beams, usually both in one roof system, both similar in appearance as they are rafters connected by a center ridge beam, except that the collar truss has a horizontal member, usually every other one or two rafters, and is used for longer spans. Collar BM, Collar Beam Forces and Reactions. As explained above for collar trusses, collar beams are normally between them. The ridge beam is supported on the collar truss. Collar beams may include an intermediate collar tie, for which calculations are provided also. Ply WD, Plywood Design and Verifications. This design module calculates plywood stresses and forces under out-of-plane loads only. It is not for diaphragm calculations. It uses dimensions provided by the APA, American Plywood Association, for fibers oriented longitudinally or transversely. JST, Floor or Roof Joist Design. The joist girder system is very common in residential structural design. Results from the joist design can be related or combined with girder design of several types, as found on worksheets hip rafter, beam, multi-girder, and composite 1. Operation of this module is self-explanatory and results are well within standard structural design methods and terminology. This module is not and should not be limited to the concept of joist as a name, because it helps designing beams or girders as deemed necessary by the user. Hip rafter, design of roof hip rafters or diagonal floor members. Design concepts on this page are very similar to those of joist design, see above, except that loading effect is different due to the diagonal condition of the hip member. which usually occurs in single-sloped roofs with rafters instead of trusses. Beam, girder design or member supporting roof or floor joists. When girders are subjected to concentrated forces, this module will allow the user a practical tool for design. Simply supported beams are studied only, which is the most common beam type in residential design. For continuous beams, the user can make adjustments using factors that he or she has the ability to enter on this worksheet. GRDR, multiple single-span girder design. When single-span beams or girders are subject to distributed loads only, this module becomes a practical tool to design up to 5 girders together on one page, except that all of them must be of the same size and material. SimCon, symmetrical bolt connections for metals. This design module with SteelCon module plus others, including wood, are also sold separately. It provides a very useful tool for connection design, which is time-consuming and many times delegated for shop drawing design. But small residences and additions do not normally allow for such luxury, and the user designer is forced to submit connection calculations. STL-Con, general bolt connections for metal. This design module with SimCon module plus others, including wood, are also sold separately. When the connection is not symmetrical, each bolt contributes to shear resistance in 2 ways. The first is its plane shear resistance with the load displaced onto the center of gravity of all bolts. The second is its share of torque resistance based on its distance from the center of gravity. MMNT, reinforced concrete design of horizontal and vertical members. This module allows for the design of 3 types of concrete structures: reinforced concrete masonry with filled cells, reinforced concrete slabs, and reinforced concrete beams. SecProp, section property calculations. This module is also offered for free on the same marketplace where you purchased this program. The section property calculations use old well-known formulas and methods based on consecutive triangular shape properties added or subtracted along the trail of XY data entered by the user in any ordinary or orderly manner, knowing on a clockwise direction, starting and ending at the same point. FTG UP LFT, vertification of footing uplift resistance. This program calculates the minimum footing size to satisfy wind uplift resistance. It uses almost all capabilities of soil and other elements to cooperate with such resistance, for which the user should exercise caution and use engineering judgment. Keywords are introduced to assist the user with information on density, sizes, etc., thus to prevent tedious research or repetitive entries. FTG HOR RES, verification of footing residential horizontal resistance. This program calculates the minimum footing size to satisfy its horizontal resistance. As well as with sheet FTG UPLFT, it uses almost all capabilities of soil and other elements to cooperate with such resistance, for which the user should exercise caution and use engineering judgment. Keywords are introduced to assist the user with information on density, sizes, etc., thus to prevent tedious research or repetitive entries. Footing design. Design of regular concrete footing under gravity forces. Regular symmetrical concrete footing under gravity load is designed with this module. It provides the option to first estimate the minimum size, then the user may select the final size for design. Using the graphs provided, input is self-explanatory. Railing, metal railing design. Steel, aluminum, copper, or bronze are common materials used for railings that are covered by this program. Wood is also very common, but is not included due to the NDS complexity, which is beyond the scope of this program. The user may still apply this program for wood design if he or she applies conservative values, used under good engineering judgment. LGM railing, light gauge metal railing design with plywood covered. This module applies to parapet railings created with plywood on light gauge metal studs, like low partition walls. It is designed with this intent only, and it is recommended not to apply it to approach another railing type. AC SUP, for design of rooftop unit support frames. This worksheet applies to the design of frames supported by rooftop equipment units, consisting of short columns with beams on top. This type of frame is called in some places as dunnage or trestle. This program calculates reactions only plus the number of anchor bolts required at the bottom of legs, short columns. SCH, Suggested Truss Connectional Schedule for Presentation. This worksheet presents a suggested schedule for presentation on drawings, based on the Florida Building Code, which requires that engineers or architects indicate truss connections on the main support structure. This worksheet does not make any calculations and has no influence on any other module whatsoever. DCE does not offer upgrade capability. If you choose a smaller package and would like to upgrade, the Marketplace website does not allow an upgrading option other than purchasing the larger package separately. However, you may contact us to discuss an upgrade service. We hope that you will select this program for purchase and will enjoy its enormous capacity in saving you substantial time and effort on your project design. The more you become familiar with it, the more you will be able to expand its use onto other types of structural design projects, including building and even industrial structures. Thank you.